Alright, this is the College Algebra Exam 2 review. We're looking at part 1, question 1. Find the distance between the points -1, 4 and 3, -6. Give the exact distance and an approximation to 2 decimal places. Well, we want to use our distance equation, which is d is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, right? So our distance is going to be equal to the square root. X2 is 3 minus a -1 squared plus -6 minus 4 squared. It's going to leave us with d is equal to the square root of 4 squared plus -10 squared, right? Means that d is going to be equal to the square root of 16 plus 100, which is equal to, our distance is going to be equal to the square root of 116, which has an equivalent of 2 square root 29, or an approximate answer is going to be the distance is going to be approximately 10.77. Okay, now looking at question 2, we want to determine the points M at -2, -3, P at 4, 1, and Q at -1, 7 from the vertices of a right triangle. So one thing that we want to do is we want to draw a graph. So it's not going to be the best graph, but so -1, 2, 1, 2, 3. This is going to be point M. And point P is 1, 2, 3, 4, 1. So we're going to be right here. Then this last point is going to be up here, right? So this is point P, this is point Q. We want to see if these make a right triangle. So it's not going to be very easy to tell off this drawing. So we need to find the distances between on each leg, right? So first we're going to find the distance from M to P. So that means we're going to have equals the square root of 4 minus a -2 squared plus 1 minus a -3 squared. That's going to leave us with the square root of 52. Now we want to do d of P to Q, have the square root of -1 minus 4 squared plus 7 minus 1 squared. And this is going to leave us with the square root of 61. Now I want to do the distance of M to Q. M to Q. So we're going to have the square root of -1 minus a -2 squared plus 7 minus a -3 squared. That's going to leave us with the square root of 101, meaning that our DMQ leg should be our hypotenuse. So, determine if this is true, we're going to do our Pythagorean theorem. So, square root of 52 squared plus square root of 61 squared is equal to the square root of 101 squared. So that's going to mean that we have 52 plus 61 is equal to 101, which is not true. So we know these are not vertices. So now looking at question 3, we want to find the midpoint of the line with the endpoints -2, -9, and -9, 4. So that means we got to use our midpoint equation, which is the midpoint is equal to x plus x2 over 2, x1 plus x2 over 2, and y1 plus y2 over 2. So our midpoint is going to be x1, which is -2, plus -9 over 2. And we're going to have y2, so -9 plus 4 over 2. We simplify this down, we're going to have m is equal to -11 over 2 and -5 over 2. So this is going to be our midpoint for those 2 points. So looking at question 4, we want to graph equation y is equal to 1/2 x plus 3 by plotting points, but we want to use a table, right? So x and y. So let's do about 5 points. So we want to start with points that are pretty easy to plug in that make it pretty simple on us. So we want to do it negative and positive x values. So let's start with -4. So it's going to be 1/2 of -4 plus 3. So we're going to be left with 1. So we have an x and a y value of -4, 1. Now, yeah, y is equal to 1/2 times what value plus 3, right? So next we want to do probably another simple value, so let's do -2. So try -2. 1/2 times -2 is -1 plus 3 is going to leave us with 2. So we have a point at -2, 2. So next we want to plug in probably just 0. 0 is pretty simple, right? So we have means we have a point at 0, 3. So 0, 3. So now let's just go back up. So let's try 2 now. So if we plug in 2, we have 1/2 times 2, which is 1 plus 3, which is 4. So we're going to have a point at 2, 4. And then now, just plug in 4. So we're going to plug in 1/2 times 4, which is 2 plus 3, so 5. We have a point at 4, 5. So now for us to graph it, I made a little graph here. So this is -1, this is 1, this is 1, this is -1, all by a scale of 1, right? So we have a point at -4, 1, so 1, 2, 3, 4. And then we're going to be going up 1, so we're going to be right here. And then -2, 2. So we're going to be going 1, 2, and then up 2, 1, 2. So we're going to have a point right here. And then now 0, 3. So we got a point right there. Point 0 up 3. Then we're going to have a point. We're going to go over 2. 1, 2, up 4. 1, 2, 3, 4. 4 right here. And now we're going to go a point at 4, 5. So 1, 2, 3, 4. And then all the way up to 5. Right. And that's going to create a straight line from here to here. So that's how we plot this equation using points. Okay, so now we want to look at 5a here. So we want to find our x and y intercepts. So we know that y is equal to the absolute value of x minus 2. So to find our x-intercept, that happens when, so x-intercept happens when y is equal to 0. So we're going to say 0 is equal to absolute value of x minus 2. So add 2 on both sides. So the absolute value of x is equal to 2. So that means that x needs to be -2 or +2 for our x-intercept. So that means we have an x-intercept at -2, 0, and +2, 0. Right? And now to find when our y-intercept, we want to plug y-intercept happens when x is equal to 0. So we're just going to plug 0 in for x. So we're going to have y is equal to the absolute value of 0 minus 2. That's going to stay 0. So we're just going to have y is equal to -2. So our y-intercept is at 0, negative 2. Now we want to find our x and y intercepts for when y is equal to x squared minus 16. So to find our x-intercepts, we want to set y equal to 0. So 0 is equal to x squared minus 16. We're going to add 16 on both sides. So we're going to have x squared is equal to 16. We're going to get rid of that square, so we're going to take a square root of both sides. But so we take a square root, we're going to have x is equal to plus or minus the square root of 16, which is equal to plus 4 and minus 4. So our x-intercepts are going to be at 4, 0, and negative 4, 0. Right? Now to find our y-intercepts, we're going to set x equal to 0. So y is equal to 0 squared minus 16. So y is going to be equal to negative 16. So our y-intercept is 0, negative 16. Alright, so looking at number 6 here, we want to find the x and y intercepts of the equation negative 2x plus 4y is equal to 12. So negative 2x plus 4y is equal to 12. So we know that our x-intercepts, we're going to set y equal to 0. So we're going to plug, it's going to be negative 2 times x plus 4 times 0 is equal to 12. That 4 times 0 is going to go to 0. So we have negative 2x is equal to 12. So now we're going to divide both sides by negative 2 to solve what x is. So our x-intercept is going to be at x is equal to negative 6. So coordinate is going to be negative 6, 0. Now to find our y-intercept, we're going to set x equal to 0. So we're going to have negative 2 times 0 plus 4y is equal to 12. So that negative 2 times 0 is going to be 0. So we're going to have 4y is equal to 12. So we're going to divide both sides by 4, both sides by 4. So that means y is going to be equal to 3. So our point is going to be 0, 3. So now to graph it, we're going to have our x-intercept at 0, negative 6, 0. Our y-intercept at this point of 0, 3. We can just draw a line. So now looking at question 7, is the point negative 2, 5 on the circle defined by x plus 2 squared plus y minus 5 squared is equal to 49. So x plus 2 squared plus y minus 5 squared is equal to 49, right? So my first instinct is just plug those points in. So we have negative 2 plus 2 squared plus 5 minus 5 squared is equal to 49, right? Those are both end up going to go to 0. So it's going to say 0 is equal to 49, which is not true. So that means that that point is not on the circle. Another thing you look at is that is actually our center point at x is equal to negative 2 and plus 5. It's actually our center point of our graph, right? And you can tell just by that this x plus 2 and that y minus 5, that's why it's our center point. So looking at number 8, we want to determine the center and radius of a circle defined by x minus 3 squared plus y minus 7 squared is equal to 36. So we know our equation is x minus x 0 squared plus y minus y 0 squared is equal to radius squared, right? Where this x is the x of our center, and that y0 is our y of our center. So just by looking at it, we can say that our center is at is at 3 and 7 by looking at these two parts of our equation, that x minus 3 and that y minus 7. And looking at our right side, we can see that 36 is equal to r squared. So we take the square root of both sides, we know that our radius is actually 6. Alright, so looking at number 9 here, we want to write an equation of the circle in standard form, given the endpoints of a diameter of the circle are -2, 4, and 6, -2, right? So if we draw this out, have -2, 1, 2, 3, 4, point here, right? And we will point at 1, 2, 3, 4, 5, 6, -1, 2. Alright, so it's going to come down here. It's going to come across like this, and here I'm going to try and draw a circle, kind of like this, right? And it looks kind of ovular, but it's a circle. These two endpoints. We want to find our center point, right? Might not be on this x-intercept, but we want to find that. So to do that, we want to find our midpoint to find what the center is. So the midpoint is equal to x1 plus x2 over 2, and y1 plus y2 over 2, right? So our midpoint is going to be x1, which is -2 plus 6 over 2, and then 4 minus 2 over 2. Leave our midpoint as negative, so 4 over 2, and then 2 over 2. Leave us with 2, 1. So right here we can see that 2, 1 is our center point. So I'm going to go ahead and erase the rest of this real quick and move that up, and we can look at it there. So that is our center point. So our center is at 2, 1. So to find our radius, we're going to take our distance formula from our center point to one of our outer points, right? So we're going to do distance is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So our distance is going to be the square root of x2, which we're going to say is 6 minus 2 squared, plus y2, which is going to be -2 minus 1 squared. So our distance is going to be the square root of 4 squared plus -3 squared. So the distance is equal to the square root of 16 plus 9. So put that in our calculator. We're going to get 16 plus 9. We're going to get 5, right? So to write our equation, in standard form, we have y. I'm sorry, we don't have y. It is x minus x of 0 squared plus y minus y 0 squared, which is equal to our radius squared, where that is our 5 is our radius, right? So our equation is going to be x minus 2 squared plus y minus 1 squared is equal to 5 squared, which is 25. So now we want to look at question 10. We want to write an equation of a circle given in standard form, and the center is 3, 1, and a point in the circle is 6, 5. So we have a circle here. We know this is our point 3, 1. We have a point somewhere across. It's going to be probably like right here, 6, 5. We need to find this distance to find our radius, right? So our radius is going to be equal to our distance equation, which is going to be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, right? So our radius is going to be equal to the square root of 6 minus 3 squared plus 5 minus 1 squared. Radius is going to be equal to the square root of 3 squared plus 4 squared, which is going to give us the 5, right? So our equation for a circle is x minus x0 squared plus y minus y0 squared is equal to our radius squared, right? So plugging in our center value and our radius, we're going to have equation is going to be x minus 3 squared plus y minus 1 squared is equal to our radius of 5 squared, so it's going to be 25. Alright, so looking at number 11 here, we want to write the equation of the circle in standard form. Of the equation is x squared plus y squared minus 10x plus 4y minus 20 is equal to 0. So we want to get this in the form of x minus x0 squared plus y minus y0 squared is equal to the radius squared, right? So first what we're going to do is add 20 onto the right side for this equation. So we're going to have n, put our terms together, x squared minus 10x plus y squared plus 4y is going to equal 20. So what we're going to have to do is complete the square twice. So for our x terms, we're going to have x squared. And to get what we need there, right, we're going to take our negative 10 and divide it by 2. So negative 10 divided by 2 is going to give us negative 5. So right here we're going to have minus 5. And then over here we're going to have plus y squared, right? So we have our 4 there. What we're going to do is divide that by 2 to give us what we need here. So plus 2. And it's equal to 20 plus, so we take our 5 squared and our 2 squared and we add it on this side, right? So plus 25 and plus 4. So that's going to leave us with our equation of x minus 5 squared plus y plus 2 squared is equal to 49. Okay, now looking at number 12, we want to write this equation in standard form of 2x squared plus 2y squared minus 32x plus 12y plus 90 is equal to 0. We can kind of see that everything is divisible by 2, so we're going to go ahead and divide everything by 2 just to make our life a little bit easier. So x squared plus y squared minus minus 16x plus 6y plus 45 is equal to 0. Right? When we get this in our standard form of x minus x0 squared plus y minus y0 squared is equal to r squared. What we're going to do is get our terms together. So we have our x squared minus 16x plus y squared plus 6y. And then we're going to move our 45 over, so we're going to have negative 45. Right? So kind of like the last problem, what we're going to have to do is complete the square of our x's and our y's, right? So if we do that, we're going to have x. We're going to take our negative 16 and divide it by 2 to give us negative 8. And then now what we're going to do is we're going to add 8 squared. So 8 squared. And now we're going to do the same thing with our y. So y, take 6 divided by 2. It's going to give us 3. Now we're going to add our 3 squared on our right side to even out our equation. 3 squared, not cubed. Right? So that's going to leave us with x minus 8 squared plus y plus 3 squared is equal to 28. Alright, so now looking at 13, we're given the functions f of x is equal to 4x minus 3, g of x is equal to x squared minus 2x plus 7, and h of x is equal to square root of x plus 3. I want to evaluate the following of the given values of x, show all work. So, wants us to know what f of negative 3 is, right? So first we're going to write what f of x is equal to 4x minus 3. So f of negative 3, anywhere we see a x, we're going to plug in a negative 3. So 4 times negative 3 minus 3. So f of negative 3 is going to be 4 times negative 3, which is negative 12 minus 3. That means f of negative 3 is equal to negative 15. Now looking at 13b here, we want to find what g of negative 5 is, right? So g of x is equal to x squared minus 2x plus 7. So g of negative 5, we want to plug in a negative 5 anywhere we see an x in our equation. So we're going to have negative 5 squared minus 2 times negative 5 plus 7. So g of negative 5 is going to be equal to, so negative 5 squared is going to leave us with a positive 25, right? Because we square a negative, we get a positive number. And then negative 2 times negative 5 is going to leave us with plus 10 and plus 7, right? So we're going to be left with g of negative 5 is going to be 42. All right, now looking at 13c, we're given that h of x is equal to the square root of x plus 3. We want to know what h of 13 is. So anywhere we see an x, we're going to plug in a 13. So h of 13 is going to be the square root of 13 plus 3. So h of 13 is going to be the square root of 16, right? And we know that square root of 16 is just 4, so h of 13 is just going to be 4. So now we want to do a 13d here, f of 4, so f of 4. So we know that f of x is equal to 4x minus 3, so f of 4. Anywhere we see an x, we're going to plug in a 4, so 4 times 4 minus 3. So f of 4 is going to be 4 times 4, which is 16, minus 3. So f of 4 is going to be equal to 13. Okay, so we want to look at number 14 now. So evaluate the function defined by f of x is equal to, so we know f of x is equal to negative x squared plus 4x for the given values of x should all work. So first we want to find what f of t is. So anywhere we see an x, or an x, we want to plug in a t. So negative t squared plus 4t. Right, and that's all that one's going to be. So, and then now for the second part, this is part A right here. So this is part B. We want to find what f of a plus h is. So for this one, what we're going to do is anywhere we see an x, we're going to plug in a plus h. So negative a plus h squared plus 4 times a plus h. Well, and then now this time we want to simplify a little bit. So this negative a plus h times a plus h plus 4a plus 4h, because I distributed that 4 to the a and the h. So for this a plus h times a plus h, we want to FOIL it out. So we're going to do our first term. So we're going to have negative times a squared, our outer term, so plus ah, our inner term, so plus ah, and our last term, h times h, we're going to have a plus h squared, plus 4a plus 4h. We're going to simplify inside our parentheses first. It's going to leave us with an a squared plus 2ah plus h squared plus 4a plus 4h. So we want to distribute that negative to each of our terms inside this parentheses. So f of a plus h. Okay, so this f plus a plus h is going to be equal to negative a squared minus 2ah minus h squared plus 4a plus 4h. Okay, so we're going to look at 15a here first. We're going to determine if each of the following determines the relation defines y as a function of x, right? So for this one, we're given a graph. So I'm going to take this straight line that I made, if it'll let me grab it. I'm going to drag it across, do a vertical line test here, and we can see that no two x values, or no one x value has two y values. So that makes a function. Okay, now I want to look at b here. So b says x squared plus y minus 3 is equal to 4. So to find if it's a function or not, we need to have an equation with y is equal to everything else, right? So we're going to start by adding 3 on both sides. So x squared plus y is equal to 7. Now we're going to subtract by x squared. So now we have y is equal to negative x squared plus 7, right? We do a quick drawing here. We're going to have plus, this is the value of 0, 7. Our graph's going to look something kind of like this, right? Parabola downwards, and we shifted it up 7. And we can see that every x value only has one corresponding y value, so that makes b is a function. So next, what we're going to want to do is look at c. So what c has is saying that negative 3 has a y of 11 when x is equal to negative 3, and when x is equal to negative 6, it has a y equal to 13 and 9. So a singular x value has two corresponding y values. It fails the vertical line test. Right? So that means that c is not a function. Okay, looking at 15D, we're given x squared plus y squared minus 6y plus 9 is equal to 4. Not really a good way to get y by itself. And you can kind of see this is going to be a circle. So we have x squared, right, plus y squared minus 6y. I'm going to move that 9 onto the left side. So equals negative 5 here. So x squared plus y minus, we're going to divide this by 2, 3 squared. And then we're going to take minus 5 and then plus that 3 squared, so plus 9. Right? So we're going to have x squared plus y minus 3 squared. It's going to give us 4. And we know this is a circle, kind of like up here somewhere, right? So since it's a circle, we have x values that have more than one corresponding y value, meaning this is not a function. And you can kind of recognize that off the bat by this y being squared and there being another y. Okay, so now we want to look at question 16. We want to use the vertical line test to determine if the given relation defines y as a function of x. So why don't we just get us a little vertical line here. Boom, okay. So I'm going to grab it, and we're going to look at question A. Right? Question A. Let's grab that vertical line that we just made. Okay, so if I drag it, we're going to start from the left, drag it across. Oh, look, we have an issue, right? For singular x values, we have other y values. So that means so we fail the vertical line test. So this is not a function. Let me rewrite that function. Not a function. Now to move on to question B. Right? Let's grab that line again. Drag it across. Look at that. For singular x values, we only have one y value. So B passes the vertical line test. So this is a function. So now for C, we drag it across, starting from the left. Okay, so for the most part, it looks good, right? But if we go to that -2 spot, we can see we have a filled-in point here at 2 and 4. So at x is equal to -2, we have two y values. So for C, we also fail the vertical line test. So this is not a function. Okay, we look at number 17 now. We determine the x and y intercepts of the following functions. Let's start with 17a. So we have f of x is equal to the absolute value of x minus 5, right? So to find our x-intercept, that happens when y is equal to 0, right? So x-intercept is when y is equal to 0. in this case f of x is equal to y. So we're going to plug 0 in here, do the absolute value of x minus 5, and add 5 on both sides. So the absolute value of x needs to be equal to 5, meaning that x can be negative 5 or positive 5, right? So our point is going to be negative 5, 0, and 5, 0 for our x-intercept, right? Now look at our y-intercept. So our y-intercept happens when x is equal to 0. So if I do that, we're going to plug 0 in for x. So f of 0 is equal to 0 minus 5. So f of 0 is going to be equal to negative 5. So we have a y-intercept at y equals negative 5. So our point there for our y-intercept is 0, negative 5. Now we want to look at 17b. So we're saying g of x is equal to negative square root of x plus 3. So to find our x-intercept happens when y is equal to 0, or in this case that's going to be our g of x. So we're going to say 0 is equal to negative square root of x plus 3, right? I'm going to add the square root of x on both sides. So that means we know that the square root of x is going to be equal to 3. To get rid of that square root, we're going to square both sides. So that means that we know that x is going to be at 9. So we have an x-intercept at 9, 0. Right? Now look at our y. Our y-intercept happens when x is equal to 0, right? So we're going to do g of 0 is equal to negative square root of 0 plus 3, right? Square root of 0 is actually just 0, so that's going to go away. So we know that when our x is equal to 0, our g of 0 is equal to 3. So our y is equal to 3. So our y-intercept is at 0, 3. Okay, so now looking at question 18, we want to write the domain of the following functions in interval notation, starting with a. We know f of x is equal to x minus 3 over x plus 7. Well, we know that if our denominator is equal to 0, we have a vertical asymptote which doesn't exist in our interval. So we need to find what value of our denominator is equal to 0. That's not going to be on our interval notation. So x plus 7 is equal to 0. So I'm going to subtract 7 on both sides. So x is equal to negative 7 is not a valid solution for x, right? So, but every other number is. So when we write our interval notation, we're going to have negative infinity to negative 7, close. Then we're going to do a union from negative 7 to infinity. Looking at 18b now, we have h of x is equal to x squared minus 5x plus 3. Right? So we know that this is a parabola function, kind of like that, right? Which has an x value of all real numbers. So that means that our interval notation is going to be from negative infinity to infinity. So next we want to look at 18c, which 18c is g of x is equal to 5 over absolute value of x minus 3. Right? So again, we want to know when our denominator is equal to 0. So we can not include that in our interval notation. So we add 3 on both sides. Absolute value of x is equal to 3. So that means that x can be negative 3 or positive 3. Well, it cannot be negative 3 or positive 3. At those values, it is not in our domain. So what we're going to do is write negative infinity to negative 3, pick back up from -3 to 3, and then we will continue from 3 to infinity. So now looking at 18D here, we have that m of x is equal to the square root of 4 minus x, right? Since we have this square root function, we know that we cannot have a negative number inside to make our solution valid, right? So we need to find a number for x that makes this less than 0, right? So we're going to make 0 equal to the square root of 4 minus x, square both sides, and then we're going to have 0 is equal to 4 minus x. So x can be equal to 4, but not greater than 4, right? Because if we looked at it and we made a number 4, or less than 4, we're going to have m of x is equal to the square root of, like, say 4 minus 3, right? That's going to give us square root of 1, which is valid, right? Now if we do 4 minus 4, it's going to be equal to 0, which is valid, right? But now let's look and do 4 minus 5. That's going to give us the square root of -1, which we can't have, right? And that's no good. So that means that we can have, our interval is going to be from -infinity, anything less than 4, and all the way up to 4, and including 4 because 0 is valid. All right, so now looking at 19, we want to use the graph of f of x to determine a through h, right? So let's look at a. We want to know what f of -2 is. So what we're going to do is go to our graph, start at 0, -1, 2. So our y value is -2. So -2. Now let's look at b. It wants to know what f of 3 is. F of 3. So if we go back here, 1, 2, x is equal to 3. F of x is equal to -1. -1. So now, find all x for which f of x is equal to -1, right? So we want to find, for c, we want to know when f of x is equal to -1. We want to find those x values. So just by looking here, we're going to go down to -1. And see, we have -1 here, and then go over here. X is equal to 3. So when x is equal to -1 and 3, then our f of x is equal to -1. We did that just by looking at the graph, going to our -1 in the y direction, and looking over. And then now if we want to look at part D, find all x for which f of x equals to -4. So f of x equals -4. We're going to use the same process. We're going to go -4 in the x direction, and we're going to go look either way of our x. And if we go this way, it's going to be equal to when our x is equal to -4. Now looking at E, we want to determine the x-intercepts, and that happens when our y is equal to 0. So when y is equal to 0, which is equal to our f of x. So if we look on our graph, that happens here at 0, 0, it's crossing, and here at 2, 0. So our x-intercepts are 0, 0, and 2, 0, right? Now looking at f, we want to determine the y-intercept, and that happens y-intercept when x is equal to 0. So just looking at our graph here, that's going to happen at 0, 0. That's where we cross our y when x is equal to 0. And determine the domain of the function, right? So now we're looking at part G, is that determine the domain of f, right? So it's valid anywhere from negative to positive. So we're just going to say it's going from -infinity to +infinity, right? And then for our last one of h, we want to look at our graph and determine our range. So, and then that -infinity is our domain. This is our range here. So if we look, our range starts at negative infinity because it's going decreasing forever, right? Then we're going up, and the highest y value we can ever reach is 1. So we're going to say that's negative infinity to 1, with 1 being included because it can be 1.
On to question 20. So we can see that x and y are linear, so we can actually solve for our y. So we get 4x plus 2y equals 2. Subtract 4x from both sides. 2y is equal to negative 4x plus 2. Divide both sides by 2. And then simplify. And we get that y equals negative 2x plus 1. But they asked for us to graph. Now we can start plugging in x values. So we can choose a few and see what the line is going to do. So let's say x is equal to negative 2. That would make y equal to negative 2 times 2 plus 1. Or y is equal to 5. Do x equals 0. That would give us y is equal to negative 2 times 0 plus 1, y equals 1. And then if we do x equals 2, just for good measure, we get y, y is equal to negative 2 times 2 plus 1, or y equals negative 3. So if we were to graph that particular one here at negative 2, we would be at 5. And then at 0, we're at 1. And then at 2, we're at negative 3. And then when you graph this line, draw the arrows. On to part B. Get y equals 1. So when x equals negative 1, y equals 1. When x equals 0, y is also equal to 1. And when x is equal to negative 1, y is equal to 1. So we're going to plot those points. Negative 1, 1. Draw a nice horizontal line. Now for C. Negative 3x equals 12, or x equals negative 4. Since x equals negative 4, y can be any value that we want. So that will give us a vertical line on our graph. At x equals negative 4.